Alright, so we're reviewing how to graph trig functions for your final exam. So let's say we have this problem right here. Y equals 3 sine 2 x minus pi over 4. What is my amplitude for this problem? My amplitude is what? 3. Very good. It's the absolute value of the number sitting up front. Period. The formula for the period is 2 pi divided by b. What's my b value here? So 2 pi divided by 2 is what? Pi. My period is pi. Remember, we have phase shift and we have vertical shift. Okay? Phase shift is what's inside the parentheses, opposite of what you think. I see negative pi over 4, so I'm actually going to put what? Pi over 4. Do I have anything sitting out here? So I have no vertical shift. Remember, these are the ones you have to draw the chart. You have 9 spots. In the top of the chart, remember, we only graph as if we had the amplitude and the period. Okay? You always start at 0. You take your period and divide it by what? What number did we take that and divide that by? 4. So this be, you start with pi over 4 and go up by pi over 4. Now sine, do you start the origin or do you start at the amplitude? Origin, very good. Okay? So I'm going to go 0, 3, 0, negative 3, 0, 3, 0, negative 3, 0. The phase shift, that affects what? Your x or y? X. So you're going to take this and add it to all the what? X coordinates. Since there's no vertical shift, you would just bring your y down. I'm not going to graph that, but the main thing was you still remember how to do table. And you would just graph that second column. Is that coming back to you? Okay. You got 2 of these on test. One's multiple choice and one is short answer. Because I have to send the short answer back to Jeff State to prove that you know how to do this. Okay, so the next one I do is on the back of your study guide. You know where it says short answer? I'm about to do this one. It's number 1. Graph the following function. So this is where I'm about to do number 1. Alright, so this is y equals 5 cosine 2x minus pi over 3. What is my amplitude there? 5. Okay, what do you notice about this one that's different from the previous one? The 2's on the inside. The 2 needs to be right out here, don't it? So I got to factor out what right here? 2. We did do some of these when we cover this, but not many. But we got to factor out a 2. When you factor something out, are you multiplying or dividing it out? Remember that. So I'm going to come over here. Y equals 5 cosine 2. Now I'm going to take pi over 3. I'm going to take pi over 3 divide by 2. So that's going to be pi over 6. You see that? Pi over 3 divided by 2. I divided that 2 out. That's going to leave a pi over 6 inside. That's why I want to make sure to go over this. After that, it's the same thing as we've been doing. So your period would be 2 pi divided by 2, which is pi. Phase shift is opposite of what you see. Pi over 6, you see negatives to be positive. And the vertical shift is none. The vertical shift would have like a plus pi or on the outside that moves it up or down, okay? Now, here's your chart for that. Okay, so the first thing, like I will graph it just using amplitude and period. I'm going to explain that to you. 0, I took my pi divided by 4, got pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Now, since this was cosine, does it start at the amp or at the origin? Amp. That's why I have 5, then 0, then negative 5, 0, back to 5, 0, down to negative 5, 0, and 5. Now, come under the phase shift is pi over 6. That means I'm going to add pi over 6 to my x. So 0 plus pi over 6 is pi over 6. There's no vertical shift. I bring my y down. Now watch this. Pi over 4 plus pi over 6 is 5 pi over 12. I know we don't work with 5 pi over 12, but that's what's going to go there. You're going to graph it just like 5 pi over 12. Pi over 2 plus pi over 6 is 2 pi over 3. 3 pi over 4 plus pi over 6 is 11 pi over 12. Pi plus pi over 6 is 7 pi over 6. 5 pi over 4 plus pi over 6 is 17 pi over 12. How am I getting that? I'm putting in the calculator. I will put 5 fourths plus 1 over 6, and you get 17 pi over 12. Is everybody understanding that? And then I just graph that bottom. Here's 5 pi over 3, 28 pi over 12. Is that 28 pi over 12? Hold on. Yeah. That's supposed to be 23 pi over 12. Over pi over 12. (23 pi over 12). And then, do I need to graph it, or do you know how to graph that then? Are we good on the graphing, or do I need to graph it? Yeah or no?
You graph it.
Okay. Now, of course, you would put 1, 2, 3, 4 all the way up to 5, but I'm doing this quick, okay? I'm just putting 5 and negative out. All right, go ahead. So I'm going to put pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, 7 pi over 6, 17 pi over 12, 5 pi over 3, 23 pi over 12, 13 pi over 6. So pi over 6 goes up to 5. And that's your graph. Are we good with that? Is that coming back to you? So you just have to be careful, guys, on the test. I think you have one where it's already in the form you want, and there's the one that you got to do. You got to factor out something, so you got to keep in mind that. Okay? Is everybody good? All right. Your limit tests are in the computer. Good job. Class average is a B. Good job. I'm gonna pass those out on Wednesday after everybody's made it up. Okay? But you can look at that. Alright, now we start our last unit today. Our last unit.
So are we going to have a test on this?
Mm-hmm. Next Tuesday. Next Tuesday is the real test. Alright. So our learning target today is I can find the derivative of f at x by using the formal definition. for the first couple days, we got to use the formal definition, which is the long way. And then after the 2 days, then I show you the shortcut, the rules for shortcuts of finding derivatives, which you like much better. But I want you to turn to page 15, please. Page 15. All right. Secants, tangents, and introderivatives. That's the name of the lesson today. Remember average rate of change? What's another word for average rate of change?
A-rock.
A-rock. That was good. Yes. But what is A-rock?
Slope.
Slope. It's a slope. Remember, when we had linear functions, you could choose any 2 points. Okay. Yeah. If we had a linear function, we could choose any 2 points on there and find the slope of that line, couldn't we? But what if we didn't have linear? What if we had quadratic or polynomial or quartic or quintic? We could pick 2 points and find the average rate of change, couldn't we? And that was the slope between those 2 points. So it was equal to the slope between 2 points. The line through the 2 points is called a secant line. A secant line. And the average rate of change, remember that formula is the f of the second point minus f of the first point divided by x sub 2 minus x sub 1. And when I say f of x sub 2, that means I got to take x and do what with it? I got to take x and do what with it? When I say f of something, plug it in. Plug it in. Very good. Plug it in. So it says for this given function, here's this given function right here, x squared plus 2. I want to determine the A-rock between the points. A-rock. Please let me have your attention. This is the last thing I ever teach y'all, guys. Last thing. So let's go out with a bang, okay? Now, I want to find the average rate of change between x equals 1 and x equals 3 up here. I want to find the average rate of change. And when I'm doing that, I'm finding the slope of this secant line right there. Sorry. I want to find the average rate of change of that secant line that connects those 2 points. So we're going to find it algebraically. Let's set it up. F of what? 3 minus what? F of 1 over 3 minus 1. We've done this before this year. Average rate of change. F of 3. I take 3, plug it in. What's 3 squared? 9 plus 2 is 11. Minus, I plug 1 in. 1 squared is, plus 2 is, 3 minus 1 is 2. So that gives me 8 over 2, which is equal to what? 4. Okay?
So how do you know to square it and do all that stuff?
How to do what, buddy? Plug it in. I'm wanting to find f of 3. So to find f of 3, I take whatever in this parentheses, I plug it in for the variable. 3 squared is 9 plus 2 is 11. Because, remember, slope is y sub 2 minus y sub 1, isn't it? So when I say f of 3, isn't that giving me my y value? Does that make sense? I know my x value. I'm getting my y value. Okay, let's look at this. I want to find the A-rock between 1 and 2 now. So M equals f of, my second point is 2, minus my first point, over 2 minus 1. If I take f of 2, plug that in, 2 squared is 4, plus 2 is 6, minus 3, over 2 minus 1, which is 3 over 1, which is equals 3. My A-rock, my average rate of change, between 1 and 2 is 3. I want you to find C, D, E, F right now. I'm going to give you a few minutes to find C, D, E, F right now. Make sure you're on page 15, please. If you see this, guys, what we did in this exercise, we were finding an average rate of change between 1 and 3. We start off between 1 and 3. Then we did what, guys? 1 and 2, didn't we? And guess what? We're slowly getting it down to what value? What we're trying to slowly get it down to? Well, I'm talking about the x values. We went from 1 and 3, 1 and 2, so we're getting down. We want to know what's exactly happening at 1, aren't we? Because your last value is 1 and 1.001. And like you said, Conley, what value did it keep approaching? 2. The limit is 2, isn't it? I'm approaching it. As I approach 1, my value is getting closer to what? 2. Okay. So that comes into average rate of change is the slope between 2 points you pick out on that graph. Guess what this rate of change is called? Instantaneous. It is what's happening at that instant. That instance. We went through from 2 points to we're down to I want to know what's going on at that single value, that instance in that graph. That's what a derivative comes into play, okay? I'm going to talk about that in a minute. But this is called instantaneous rate of change. You've never worked with that. You've worked with slope and rate of change, average rate, AROC. This is called IROC, okay? IROC. So, if A, yes?
I don't see on the graph how it's like approaching 2. Where is that?
What now? Well, that's just Hold up, I'll look at that in a minute. Let's go on. Alright. If a of x is the a-Rock function, what would you guess as x approaches 1? Equals. Okay, we plugged it in. It is 2. Okay, so when you're talking about instantaneous, I'll look at that in a minute, okay? The instantaneous. When you're talking about just one point, I'm trying to pick a point. If you're talking about just what is the slope at one time,
It's going to have a different. I need the following students to name off. Please listen carefully, students. I need Ebony Gaddis, Tanea Miller, Carson Burke, Avery Forrest, Tobias Shelfer, Emily Sandiford, Chelsea Ferguson, Joseph Ford, Nathan Kitchmana, Jalen Lewis, Madeline Oliver, Kirsten Boyd, Sarah Frazier, Connor Fulford, Mallory Bailey, Simon Callahan, Lily Champagne, William Connor, Cameron Keel, Bailey Kinsey, Misty Medina, James Mosley, Kaylee Meads, Lauren Phillips, Jalen Raymond. That's the James Mosley, Mosley. Those students need to come to the main office, please, at this time. Thank you.
alright, so, okay guys, let's get back to this, okay? So, we're talking about I-Rock. So, if I want to know the I-Rock, the instantaneous rate of change, that's a tangent line because you're touching it in one spot. A tangent line is in one spot. A secant line is in two spots. You see how we're touching two? So this is dealing with tangent. This is your instantaneous rate of change. What the rate of change is exactly at 1. As your secant lines go through the points closer and closer to 1, they tend to look like the same line. This line that you were getting closer to, approximately the tangent line. Oh, I know what it is. That is the slope of the tangent line. What the slope of this line is, not the graph right there. Yeah, the graph's approaching 3, but we're talking about what the slope of this tangent line is. Does that make sense? Okay, so, yes, it's approximately 3, but we're talking about what is the slope of. You're not going to be able to see this in the graph because it's not going to be exact. But this right here, this is the slope of that line right there. Like, I can't draw that perfect, okay? But that is what that's referring to, and not the y value there, okay? It's the slope of that line at that point. Does that make sense, guys? Yeah. That's the slope of that line going through that point right there. Does that make better sense? Okay. Now, turn to page 17. We're going to skip on page 16 because you don't have time for all that this in a week and 2 days. All right. You're getting the big ideas in this unit. All right. No, this is... Oh, no. You got to know this before you go to Miss Ranello. All right. So let's look at the big ideas. The slope of the secant line through 2 points is the average rate of change. A secant line touches in 2 points. Like a while ago, we had between x equals 1, x equals 3. That is a secant line. The slope of the tangent line at that point is your I-Rock, your instantaneous. At that instance in the graph, what is the slope of that function, okay? The graph that represents the slope of the tangent line. Okay, whatever the graph of that tangent line is, that is known as the derivative. That is your derivative. All of calculus is based on limits and derivatives. You understood limits? Now we're talking about the derivative. And it's called AKA the slope generator. It's a slope generator for that tangent line. Now, the derivative, now this is how this is written. The derivative of f of x is written as this. F, you see that little apostrophe right there? That's called f prime. You can read it as f prime of x. Say it, f prime of. Or it can just be f prime. It is pronounced f prime of x or f prime. If the original function is given as y equals, the derivative is written as y prime, or that's the other notation. You can see that little apostrophe, or you can say it dy over dx, that's derivative. So you can either see a apostrophe or this, that means derivative notation. Okay? So it's important to know that both of those notations. These are all notations for derivative. Now, this is the formal definition of a derivative. This is the formula right here. Derivative equals the limit as h approaches 0 of f of x plus h minus f of x over h. What do you, since this is in parentheses, what do you think we're going to be doing with both of these?
Back.
Plugging it into something, okay? This is another name for this, called difference quotient. It comes from a formula called difference quotient. Now, directions. It says find the derivative of f at x. That is, find f prime of x. After you find the derivative, this is AKA slope generator. Find the slope of the tangent line to the graph of f at each of the following two values. So right now, we're going to find the derivative of this. And then after we find the derivative of this, I want to know what is the slope, the IROC at -2. I want to know what is the instantaneous rate of change at -2. Then I want to find the instantaneous rate of change at -3/2 of the graph. Do you understand what I'm saying? So first, I'm going to find my slope generator, the derivative, and then I'm going to find what the slope is at both of those points. Okay? So I'm going to find this. Now, I'm going to write this on another piece of paper so you see this, but I got to plug this right here. So my original function is x squared plus 3x, and I want to find f prime of that function. F prime of that. I got to use this formula. The limit as h goes to 0 of f of x plus h minus f of x over h. Now, guys, I got to come over here to the side. I got to find out what f of x plus h is and f of x before I can even substitute it in the problem. So I'm going to come over here and find f of x plus h. So my original problem is x squared plus 3x. I'm going to take that and plug that in. X plus h squared plus 3 times x plus h. I'm finding what f of x plus h is. I take that, I plug in the original function. Now, I got to do what with that? X plus h squared, I got to do what with? Foil it out, don't I? By now, every one of you are intelligent. You should be able to do that in your head. That would be x squared plus 2xh, or you could have hx, either way, that is fine, plus h squared, distribute 3x plus 3h. If you need to foil it out, foil it out. I'm not going to do that, but you know I got that. Now, I need to find f of x. I take x, plug it in, it doesn't change it, does it? So these two things are what I sub into my formula here. That goes first. The limit as h goes to 0, x squared plus 2xh plus h squared plus 3x plus 3h minus, that's a minus, x squared plus 3x all over h. What does this minus do to everything in that second parenthesis? Changes the signs. Changes the signs. So here we go. The limit as h goes to 0, x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x all over h. Can you cancel some stuff out? Boom, 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 boom. At that point, guys, of this problem, everything that doesn't have an h should cancel out. If not, then you did something wrong. Did you notice all those didn't have an h? Okay. So you're left with the limit as h goes to 0 of 2xh plus h squared plus 3h over h. Now we just take the limit. Can I do direct substitution here? If I plug 0 in there, would that work? No, because I get a 0 in the what? What toolkit strategy could we do? I could factor out an h. These cancel out. Now can I do direct substitution? Plug 0 in for h. You said, Mr. Harris, how do I know which one plugging in? It's h approaches 0, so you plug 0 in for h. So you're just left with 2x plus what? 3. That is your derivative. That is your derivative. You say, okay, Mr. Harris, tell me what that means right there. That's your derivative. That means that is the equation of your tangent line at any point on that graph. Like that's the equation. Y equals 2x plus 3. 2x plus 3. So if you want to know what was going on at x equals 1 on this graph, you plug in 1. 2 times 1 is what? 2 plus 3 is? That is the slope of the tangent line at that very point in time. That's your IROC. That's your instantaneous rate of change. Does that make sense now? That's the slope of that tangent line at that instance in the graph, okay? So, let's look at this. I want to know what my slope is at x equals negative 2. Where would you plug this in at? This is your derivative. That's your aka slope generator. So I will take it, plug negative 2 in. 2 times negative 2 is what? Negative 4 plus 3 is? That will be your value of the slope at that x equals negative 2. That's your IROC. Now, that's your derivative. That's your aka slope generator. That is your IROC at that moment. That's the slope. Now, let's talk about something. We will finish this tomorrow. You don't have any homework because we didn't get far. Okay, so at this point in the graph, I got a negative 1. What does that tell me? Since your value, the slope, that means the graph is decreasing there. If you got a positive value after you plugged it in, that means your graph is what? Increasing. If you get 0, that's a special point. That's like a local min or max. That's where it's a turning point, okay? Does that make sense? So this is your derivative. What does this tell you? This is your aka slope generator. This tells you your instantaneous rate of change. This is the graph of the tangent line that you can use to find the IROC. Once you get your IROC, if it's positive, that means the graph is increasing. If it's negative, the graph is decreasing. But the derivative is the equation of the tangent line. Does that make sense now? This is the long way, and we're going to do one more day of the long way, and then I'll show you the shortcut. Okay, the shortcut's a lot quicker than that, okay? But do you understand the terminology today? Yes. Yes. So you would write it. Okay, great thing, Taylor. Taylor just said this. Okay, how do you want us to write the derivative? You would go f prime x equals 2x plus 3. Do you see, all eyes up here. You see how I wrote that final answer. The derivative is f prime x equals 2x plus 3. Do y'all see that? Okay. So that is the graph of the what line? That is the equation of the what? Tangent line. Once you have that, if I want to know the slope at any given point, I would take that number and plug it in for what? X. If you get a negative value, the graph is what? If you get a positive, it's what? If it's 0, it's a local min or some type of turning point, yes. Do y'all understand that? But this is the basis of all calculus. Limits and derivatives. We didn't get a chance to do negative 3/2, but you plug it in. When I plug negative 3/2 in, guys, I got 0. So it's a what? Either a local min or a max. And if we graph that, do you see that negative 3/2 is where the vertex is? Do you see that as a turning point? Have a great day. Good morning. Hey, you okay? Yeah. What's wrong? Go home. Oh. Already. Didn't even have a class here. We're going to go over today. So this Good morning. Good morning. I'm still recording.